Unveiling solar system secrets beyond textbooks. Welcome! Our universe and our very own place in it, the solar system, is a fascinating spectacle filled with mysteries and wonders that we've only started to understand. Today, we will venture to the corners of the solar system that textbooks seem to frequently overlook. From the age of the solar system to the demotion of Pluto, from sideways rotating planets to two-toned moons, we'll uncover the unusual, the bizarre, and the downright mind-boggling facts that lie beyond the familiar faces of our cosmic neighborhood. Fasten your seatbelts, space explorers, as we embark on a cosmic adventure. Ancient Echoes, Secrets of the Solar System's Age. Our solar system has been performing its celestial dance for an astonishing 4.6 billion years. But how do we know this? The answer lies scattered across our solar system in the form of meteorites. These cosmic time capsules, remnants from the early solar system, hold within their structure the secrets of our cosmic dawn. Scientists, using radiometric dating techniques, analyze the radioactive isotopes within these meteorites. These isotopes decay at a predictable rate, acting like cosmic clocks, allowing us to determine their age and, in turn, the age of our solar system. Each meteorite, a silent storyteller, whispers tales of a time when our sun was a newborn star, surrounded by a swirling disk of gas and dust. Venus, Earth's twin with a turbulent secret. Venus, often called Earth's twin due to its similar size and composition, harbors a secret so extreme that it makes the wildest hurricanes on Earth seem like a gentle breeze. High above the scorching surface of Venus lies a layer of atmosphere so turbulent that it whips around the planet at speeds exceeding 220 miles per hour. That's 50 times faster than the Earth's rotation. The exact cause of Venus's superrotation remains a mystery, a puzzle that continues to intrigue and baffle scientists. The long goodbye, exiting the solar system. But have you ever stopped to consider just how far you'd have to travel to truly leave our solar system behind? Buckle up, space cadets, because the answer is a mind-boggling 11 billion miles. This boundary, known as the heliopause, marks the point where the sun's solar wind gives way to the interstellar medium, the space between stars. It's a cosmic frontier, a point of no return where the influence of our sun finally wanes. Reaching the heliopause is no mean feat. It took Voyager 1, the farthest human-made object from Earth, over 35 years to reach this distant frontier. Chapter 4. The Martian Methane Mystery. Mars, the red planet, has captivated our imaginations for centuries. But beneath its dusty surface, Mars harbors a mystery that has puzzled scientists for decades: the enigmatic presence of methane gas. Methane, a simple molecule composed of one carbon atom and 4 hydrogen atoms, is a tantalizing discovery because on Earth, it is primarily produced by living organisms. The detection of methane in Mars's atmosphere raises the tantalizing possibility that life, in some form, may exist or have existed on our celestial neighbor. Adding to the intrigue, the amount of methane in Mars's atmosphere isn't constant. It fluctuates, rising and falling in ways that scientists have yet to fully explain. Some scientists speculate that the methane could be released from underground reservoirs, trapped within Mars's rocky interior for billions of years. Chapter 5. Pluto, the rise and fall and rise of a planet. Few events have sparked as much debate as Pluto's demotion from a planet to a dwarf planet in 2006. Discovered in 1930, Pluto held a special place in our hearts. But as our understanding grew, we found Pluto wasn't alone in space. Other objects, some larger, were found in the Kuiper Belt. This led to a reassessment of what defines a planet. Pluto met 2 criteria but failed the third. Chapter 6. Uranus, the sideways world. Imagine a world tilted on its side, its poles pointing towards the sun as it spins through space. Unlike the other planets in our solar system, which spin on their axes like tops, Uranus is tilted at an angle of about 98 degrees, meaning that it essentially rotates on its side. This unusual orientation gives Uranus the most extreme seasons in our solar system, with each pole experiencing 42 years of continuous sunlight followed by 42 years of darkness. Some scientists speculate that it was caused by a cataclysmic collision with a massive object, perhaps a rogue planet or a large protoplanet, early in the solar system's history. Others suggest that Uranus's tilt might be due to the gravitational influence of its massive neighbors, Jupiter and Saturn. Chapter 7. The Sun, our very own star, the celestial anchor that holds our solar system together, is a force to be reckoned with. It's a giant ball of plasma, a churning inferno that constantly fuses hydrogen into helium, releasing an incredible amount of energy in the process. But the Sun's influence extends far beyond its visible surface. Its gravitational pull governs the orbits of all the planets, asteroids, and comets in our solar system, keeping them in check like a cosmic shepherd tending its flock. The Sun accounts for a staggering 99.86% of the total mass in our solar system. This overwhelming mass is what allows the Sun to exert its gravitational dominance, shaping the orbits and destinies of all the objects within its reach. It's also the lifeblood of our solar system, providing the light and heat that make life on Earth possible. Chapter 8. Mercury, the smallest and innermost planet in our solar system, is a world of extremes. Scorched by the Sun's relentless heat, its surface bakes at temperatures hot enough to melt lead. Yet, despite its seemingly desolate nature, Mercury harbors a secret that hints at a more dynamic past, possible evidence of tectonic activity. Tectonic activity, the movement of a planet's crust, is a sign of a geologically active world. Evidence for Mercury's tectonic activity comes from NASA's Messenger spacecraft, which orbited the planet from 2011 to 2015. Messenger's observations revealed the presence of fault scarps, cliff-like features that form when one side of a fault is pushed up relative to the other. These fault scarps suggest that Mercury's crust is still contracting, albeit slowly, as the planet cools and shrinks. Chapter 9. Asteroid belts, cosmic misconceptions. Asteroid belts, those celestial minefields of rock and ice, have long captured our imaginations, often depicted in science fiction as treacherous regions where spacecraft must navigate through a dense and deadly maze of debris. But in reality, the asteroid belt is far less crowded and far less dangerous than Hollywood would have us believe. The asteroid belt, located between the orbits of Mars and Jupiter, is home to millions of asteroids, ranging in size from tiny pebbles to dwarf planets hundreds of kilometers across. But despite their vast numbers, these asteroids are spread out over an incredibly vast region of space. The average distance between two asteroids in the asteroid belt is estimated to be about 965,000 kilometers, or about 600,000 miles. So, while it's true that collisions between asteroids do occur, they are incredibly rare events. Chapter 10. The Kuiper Belt, a realm of ice and mystery. Far beyond Neptune, in the frigid depths of our solar system, lies the Kuiper Belt, a realm of icy objects and dwarf planets. Stretching from about 30 to 50 astronomical units from the Sun, it dwarfs the asteroid belt. Billions of objects orbit here, remnants from the early solar system, frozen in time. The Kuiper Belt is also home to several dwarf planets, including Pluto, its most famous resident. Chapter 11. Pluto's cryovolcanoes, Eruptions of Ice. Pluto, once relegated to the status of a dwarf planet, continues to surprise us with its unexpected and awe-inspiring features. One such feature is its cryovolcanoes, icy counterparts to the fiery volcanoes we know on Earth, spewing forth not molten rock but a chilling mix of water ice, methane, nitrogen, and ammonia. Imagine standing on the surface of Pluto, gazing upon a towering cryovolcano, its slopes sculpted by eons of icy eruptions. Instead of fiery lava flows, you'd witness a slow, creeping expanse of slushy ice, a frigid slurry of water, methane, nitrogen, and ammonia oozing from the cryovolcano's vent. Scientists believe that the heat generated by the decay of radioactive elements within Pluto's core, combined with tidal forces exerted by its large moon, Charon, creates enough internal pressure to melt the icy materials and drive these cryovolcanic eruptions. Outro: the universe of wonders, and it doesn't stop there. The Milky Way alone houses about 100 billion solar systems, and even meteorites found on Earth were discovered to have originated from Mars. And did I mention that Jupiter's moon, Io, is a chaos with active volcanoes, and Mars houses the largest volcano? And we've not even started talking about the moons of some small celestial bodies. We hope this cosmic journey has left you excited, and we need your help to keep exploring. If you have any unusual solar system facts, do share them and keep exploring.